However, in 1928, Sir Alexander Fleming marked the start of the antibiotic revolution, creating a new vision and standard for modern antibiotics. The use of antibiotics in medicine revolutionized the treatment of infectious diseases. With antibiotics, less people die from infections, leading to a jump in life expectancy from 47 years to 78 years. Well, antibiotics are small molecules which infiltrate into bacteria cells and eradicate them by striking and placing pressure on the machinery that makes the bacteria cell wall, so the membrane bursts, or through the assault of protein synthesis in the cell or DNA so it can't replicate, as without intact DNA, bacteria cannot live or reproduce, thus prohibiting the growth of bacteria. However, we're at a risk of losing them. We now live in an era when people around the world, including Americans, are dying from untreatable infections because of the emergence and spread of antibiotic-resistant bacteria. The ability of microorganisms to develop in the presence of a chemical drug through mutated genes and through a process known as natural selection, often caused by excessive use or misuse of antibiotics, according to U.S. Centers for Disease Control and Prevention. Bacteria can spread immunity through exchanging plasmids to transmit useful abilities, or harvest the bacteria and collect DNA pieces through a process called conjugation, thus leading to superbugs. With this information on antibiotics and antibiotic resistance, we want to help you become more aware of the dangers of the misuse of antibiotics, because something as simple as not taking or taking it when you're not supposed to can lead to the spread of a superbug, possibly resulting in a post-antibiotic era. The antibiotic-resistant crisis is becoming a major concern for the United States because of its high mortality rate and health concerns on the society, contaminations to the environment, its economic burden and expenses, as well as effects on government and governmental organizations.
The increasing issue of antibiotic-resistant bacteria in the U.S. can be attributed to social factors such as a higher chance of death and illness, higher medical bills and treatments, and more side effects from a variety of powerful medications. Antibiotics have helped save lives for the past centuries. In the 20th century, the supply of penicillin was limited as there was a high demand for it. During World War II, because of penicillin, the number of deaths were reduced. This implies how antibiotics have been extremely helpful to treat infectious diseases. Without effective medicine, pneumonia is deadly. Infections have also decreased due to the antibiotics and clean water and sanitation. Also, without antibiotic treatment, infections from stepping on sharp stone, getting stung by a wasp, and more can be deadly. When mothers give birth, 10% of them die because of infections that could have been treated with antibiotics. Not only does it help with infections, but it plays a big part in surgeries too. Antibiotics are very important in surgery as they prevent infections. Antibiotics have helped advance intensive or critical care in hospitals around the world. There are some patients that have weakened immune systems and are prone to infection. Without antibiotics, these patients aren't able to receive immunosuppression treatment. Due to social class, those in developing countries aren't able to afford the needed antibiotics, therefore are more likely to suffer from infection. The more people that take antibiotics unreasonably, the more people are going to be immune to it, which means that the more and more people won't get the treatment they need. In order to prevent disease and bacteria from harming the body, antibiotics are needed. Globally, the concern of antibiotic resistance increases every day, which means our ability to cure and treat common infectious diseases are hindered. Antibiotics become less effective, infections become harder to treat. Practicing safer sex, having good food hygiene, washing your hands, and getting vaccinations are all important aspects of reducing the spread of infections. Antibiotic resistance will always be an issue if we don't change our behavior and improve our actions. Because infections can't be treated by first-line antibiotics, the medicines that are more expensive have to be used. This means that those in the lower class in developing countries won't be able to afford proper treatment for their infections. Many advanced modern medicine have been put at risk due to the fact that antibiotics play a big part in preventing infections. These modern medicines include chemotherapy, surgery, and organ transplants. Due to antibiotic resistance, hospital stays and expenses keep increasing, and the more people are at risk, especially those who have weak immune systems. Groups that are more prone to infections include infants and seniors. According to many imperial studies, in low and middle income countries, antibiotic resistance have often spread between the communities. This is well noted as many parts of the world. However, there are barely any studies that show how it works, which is important for solving the issue of antibiotic resistance. An important factor of global health is why antibiotic drug resistance affects different parts of the world differently. In some parts of the world, it's being controlled. However, in places like India, China, and Africa, the issue is growing. This is suspected to be due to an increasing economic gap between developing and developed countries. Without socioeconomic growth, spread of infectious diseases and misuse of antibiotics can cause an entire society to become infected with an antibiotic-resistant infection.
Antibiotic-resistant bacteria growing in antibiotic-contaminated environments threatens both global health and the Earth's ecosystem. Resistant bacteria that may transmit from contaminated environments threatens human populations, agricultural communities, livestock, and microorganisms, potentially fueling a growing global health crisis. How does antibiotics positively affect the environment? Antibiotics are created by observing naturally occurring phenomena. Scientists are then able to create antibiotics by using their knowledge about natural microorganisms' defense systems. Antibiotics can also help vulnerable animals, which can be beneficial when increasing the population of endangered wildlife. Do antibiotics negatively affect the environment? Our environment globally is contaminated with antibiotics. This creates a breeding ground for resistant bacteria. Resistant bacteria can be transmitted through both humans and animals. With resistant bacteria growing in environments, certain microorganisms fail to protect themselves and die from disease. This causes an imbalance in the food chain, affecting the entire ecosystem. Researchers in Indianapolis, U.S., investigated the effects of antibiotic-contaminated water on algae and animals in 2017. Their investigation analyzed river water nearby major pharmaceutical plants. High levels of antibiotics stop all algae growth, decrease bacterial diversity, and the few fish embryos which were found had development issues. It was also found that the disease could be passed on from humans to coral reefs, now known as reverse zoonosis. Antibiotic pollution has the potential to destroy our marine ecosystem as well. Why is our environment so polluted with antibiotics? Typically, when a patient consumes an antibiotic, 30 to 90% of the active compound is excreted. Globally, 2/3 of the antibiotic produced are used in agriculture for livestock. These excretions can contaminate soil, which can run off into rivers, groundwater, or lakes. Livestock can become vectors for disease, as human population may consume contaminated meats. 33% of the rivers in America were shown to exceed safe limits for antibiotic contamination. Antibiotics, one of the greatest medical innovations, is proving to be deadly to our fragile ecosystem. The bacteriophage, a potential solution to antibiotic-resistant bacteria crisis. The bacteriophage is a virus towards bacteria. Phages are deadly towards bacteria, however, they do not harm our cells. Unlike antibiotics, phages have the ability to evolve. As a bacteria becomes more resistant to specific species of phages, it loses its ability to be immune towards antibiotics. In 2016, the largest phage clinical testing began in the US. The effectiveness in reducing antibacterial resistance in the US. Drinking water supplies in the United States are among the safest in the world. However, it can be contaminated with antibiotic-resistant drugs such as E. coli, hepatitis A, and other pathogens. According to the CDC, water purification is currently not one of the U.S.'s priorities. Agriculture and antibiotics are being reduced by 10% in the U.S., according to the CDC in 2019. However, their progress was not sufficient, and the CDC urges communities to reduce their antibiotic usage by at least 50%. In the U.S., deaths are slowly shown to be decreasing by 18% since the 2013 CDC report.
Hi, my name is Edie Bellingham and I'll be doing the economic factors. The increasing economic concern of antibiotic-resistant bacteria in countries such as the United States can be attributed to the excess healthcare expenses, the loss of productivity caused by unemployment and illness, and the continued decline of antibiotic profitability resulting in market failure. As antibiotics are usually included in a bundle of payment in US hospitals, it gives strong financial incentives to curb the implementation of more costly drugs unless clinically necessary. Additionally, these are the average cost for different types of antibiotics at retail pharmacies as shown on the screen. Because of the comparatively inexpensive prices for antibiotics, patients can afford the necessary medications for bacterial infections. However, there are several downsides to this once deemed miracle medicine. Looking at a different perspective, in a 2017 report, the CDC reported that in the United States, 47 million unnecessary antibiotic prescriptions are issued annually, often mistaken, as an example, for viral infections that do not respond to antibiotics. Ineffective medication and prolonged illness can lead to expensive hospitalization and the need for further diagnostic testing and X-ray scans, placing significant economic pressure on patients. Additionally, healthcare spending for patients with resistant bacterial infections is 165% higher than for patients with non-resistant infections. The provision of care becomes more complex as families can suffer economic losses as a result of low income, and unaffordable costs for treatment can lead to an increase in mortality rates. Secondly, antimicrobial resistance also has a major impact on labour through the loss of productivity caused by unemployment and infections. The CDC estimates that antibiotic resistance causes 600 million days of lost productivity annually in the US, resulting in $2 billion of productivity losses every year. The increase in resistant infections reduces the quality and quantity of the supply of labour, hampering production activities. This also leads to another concern regarding a reduction in demands for goods and services, as producers will need to reduce the use of labour inputs, causing unemployment and a reduction of household income and overall economic growth. Finally, for decades now, infectious disease experts have been fretting that the new FDA approvals for antibiotics are at an all-time low, as new antibiotics that many consider as a solution for antibiotic resistance are often only effective for a narrow spectrum of infections, whereas the first ones have been broadly applicable. Fewer of these drugs could be sold, making them less profitable. Large companies that once dominated the discovery of antibiotics have exited, including Novartis, arguing that the prices they charge for these life-saving drugs are too low to justify the expense of producing them. Now that we discussed the effects that antibiotic resistance poses on the economy, let's explore how the economy can affect antibiotic resistance. Through interdisciplinary correlations, the economy can present numerous benefits of the solving of antibiotic-resistant bacteria, motivating and enabling people to invest in their health, whereas its absence does the reverse. Private research firms and pharmaceutical companies should be given economic incentives to develop new antibiotics for eventual market release. Such an initiative might only be successful if there are broad buy-in from institutions that finance academic and commercial pharmaceutical productions, with the benefits varying from profit and then potentially being more effective than existing pharmaceuticals. Additionally, following new innovative antibiotic stewardship programs designed to spread awareness, such as CDC's Get Smart in the US, it minimizes unnecessary prescriptions of antibiotics, estimated to have saved 37,000 lives, thus lowering costly economic concerns by $200,000 to $400,000.
Political movements, decisions, and policies have both positive and negative impacts on antibiotic resistance in the USA, which has contributed to scientific processes that have led to improved policies addressing antibiotic resistance, a lack of food security, as well as challenges for public health departments to limit widespread infections. So far, the United States government has implemented multiple policies, including the Veterinary Food Directive. VFD, for short, is an authorization that only allows veterinarians to administer antibiotics in animals' feed and water. In the next couple of years, the US government has attended and held meetings with the United Nations. In the future, they are planning on developing new antibiotics, alternatives for antibiotics, improved methods for detection, and much more. Yet, there is a lack of global effort in order to eradicate the issue of antibiotic resistance. The United States government also needs to implement policies that address a responsible use of antibiotics in agriculture and food. However, this is only on a global scale. Local leaders need to step up as well. A great deal of antibiotic-resistant infections spread from contaminated food. Some farmers give their animals antibiotics to help enhance the growth. The unnecessary use of antibiotics then gets consumed by humans. By definition, food security is when all people have a stable and safe food supply. If there is a risk of epidemics caused by consumption of contaminated food, it means that the US would have a lack of food security. On the other hand, antibiotics have ensured that animals don't spread diseases to humans. Additionally, antibiotics help to enhance food production. Research has shown that small doses of antibiotics can greatly increase the amount of food an animal produces. According to a study done by He et al. And Zhou et al. In 2011, the pigs gained 25 to 40% more weight compared to those who did not receive any antibiotics. In 2015, former President Obama said that drug-resistant bacteria are one of the most serious public health issues we face today. They cause tens of thousands of deaths, millions of illnesses, and that's just in the United States. and the numbers are sure to climb unless we take some very clear, concrete, and coordinated action. By definition, public health is being able to make sure that the health of people and their communities is constantly improving. By not acting against the spread of antibiotic-resistant infections, we are putting large communities at risk of epidemics. Additionally, large groups of people often buy produce originating from the same farm, generally meaning that all the animals from the farm could carry antibiotic-resistant bacteria. On the contrary, antibiotics have helped save many lives, thus ensuring public health doesn't become as severe of an issue.
Antibiotic resistance is not only a U.S. problem, it is a global crisis. The war against antibiotic-resistant bacteria results in high mortality rates and health concerns for society, contamination to the environment, a costly economic burden, and effects on government organizations. Some final words of wisdom are to remember this quote: "Sniffle, sneeze, and no antibiotics, please."